Yes, hi. Hi, everyone. Good morning. How you guys are doing? All right. So, let us continue with our last session. Let us continue with that. So, what was the last topic that we have discussed, guys? What did we study in the last session? What did we study in the last session? We worked on some data. Oh, is it? Okay. Just a minute. Just give me a minute, guys. I'll just share my screen. I think there's something working in the background. I need to check this. So in the last session, that is 12th Jan, we have seen hierarchical clustering, I think, and we were working on some data, right? This one. Do, do, do. Yeah, here itself, in mall customer here itself, we were working on this data, right? Yeah. Just give me a minute. I'll be back in a minute. Yeah. I think it is resolved now. All right. So, um, did we complete the hierarchical clustering part? Is that done? Mhm. Yeah, we already have completed hierarchical. All right, perfect. Let us move to the next algorithm, that is PCA. And let me tell you, this is going to be a very, very important session for you in terms of understanding wise, or in terms of your interview wise, or let it be anything. Like, if you compare the importance weightage for this model, it is going to be very, very crucial, right? So let's call this as 18th Jan 2025, and let us start with unsupervised approach. And this is our, what we can say, friend for a life, or this is going to be saliva for us, right? Why this is going to be saliva for us? I'll be explaining this thing only in this entire session, right? It covers majority of the problems, one solution. If we have multiple problems, like if you have multi-collinearity problem, right? You go with PCA. If you have, let's say, dimensionality reduction problem, like there are a lot of variables which are not important, and you're stuck in that process wherein you are interested to understand the importance of that particular variable, like which variable we should remove, which variable we should consider. Very simple solution is uh, just go with PCA, right? So neither we should go with VIF, p-values. That there are certain techniques that we have discussed in multiple linear regression, but the best possible case scenario or solution is going to be your PCA, right? So let us call this as saliva, right? All right. So in order to start with this, in order to start with this, you should start, or you should, what we can say, understand which part? The very basic part of PCA, that is introduction. So we are going to see introduction, and we'll see what is PCA and why there is a need of PCA, right? So let me just increase font little bit for this. This should be bold, right? So PCA, its full form is Principal Components Analysis. PCA, Principal Component Analysis. And it is one of the most commonly used dimensionality reduction techniques in the industry. What is dimensionality reduction technique, guys? What do you mean by dimensionality? What do you mean by dimensionality reduction? One of the most commonly used dimensionality reduction techniques. What do you mean by this, guys? What is dimensionality reduction? Basically, it converts large data sets into smaller ones containing what? Only fewer variables, you can say, right? And it is going to be help you out. It helps in improving model performance, visualizing complex data sets, right? And in many more areas. In many more areas. So let us try to see how this generally converts it into smaller data set, right? So in this module, you will be studying the PCA. What are the necessary prerequisites for the same? There's no any prerequisite for this, but you should know fundamentals of PCA. That is, you will divide this entire uh, module into two types. First is going to be fundamentals of PCA, wherein you will get an idea why you should learn about PCA and its essential building blocks before understanding the process. And this has been divided into two subsessions, wherein we are going to see fundamentals of PCA 1, and we are going to see fundamentals of PCA 2, right? And then last but not the least, second part is going to be PCA using Python, wherein we are going to work on two major data sets or projects, you can say. We'll implement PCA using Python and get various uh, get to know basically get to know various or its various applications. Get to know its various applications. So this model requires prior knowledge of certain linear algebra like matrices, vectors. Anyway, if it's not comfortable, I'll explaining that particular part for you, right? So let us move forward with this. Let us try to understand the why of PCA. Why PCA is needed, right? So to give you guys an idea about this, why PCA is needed, let us see. Um, yeah, let us see certain situations where PCAs are important, right? Let's see that. So, situation one for us is we are interested to build a predictive model. Any model, let's say linear regression, logistic regression, any predictive model. The problems that are with me are I have a lot of variables, right? Suppose I have 20 variables, 20 columns, 30 columns, 40 columns, 100 columns, right? And I have correlation between the variables. That is your multicollinearity. That is my multicollinearity. What is multicollinearity? It is nothing but uh, independent variable are strongly correlated with each other. So we are not able to identify the effect of one independent variable with respect to target variable. So individual effect are something which we are missing if we are having multicollinearity, right? So the solution for this problem is how we used to tackle this earlier. What we used to do is we used to do manual feature selection. Yes or no? Recursive feature selection manually. So we used to build a model, right? Then we used to drop less variables. We used to drop variables which has less p-value. So drop less useful variables. Yes or no? Which has high p-value. Then we drop redundant variables. How do you do that? By using VIF, right? By using VIF. So we used to drop redundant variables. What is redundant variables, guys? The variables or the columns which are least important are not important for us. When it comes to any scenario, let's say you are predicting price of a car or price of a, let's say price of a car or mileage of a car, mileage of a car, and you have multiple, let's say car CC is important for us, weight of engine is important for us. But let's say if you have some columns like car manufacturer, right? Its manufacturing year, or for that matter of fact, color of a particular car, right? Country of that car. It's not important for us to find the mileage, right? So these are the redundant variables. So we use VIF test. VIF is something which we already have discussed, so I'm not going to repeat that. But I hope you guys are getting this, right? And then last step, what we used to do is to rebuild the model, and we used to repeat this, right? Are you guys with me now till this part? Can I get response? Yes. What about other guys? Perfect. Excellent. Right? There is what we can say solution 2, which is your automated, right? Automated feature selection. So what we used to do over here is we used to use method like RFE. We used to go with the forward slash backward slash stepwise selection based on AIC, and we used to go with lasso regularization. Lasso regularization. What is that? I think we have not discussed. So let's discuss this in the other half of this particular course. I mean, this session. The second half, we'll discuss this in second half today, right? So we used to have some forward, backward, stepwise selection, AIC, right? We already have discussed this, what how we used to do RFE. We used to, remove certain features. Suppose we have 50 variables. We used to drop this down automatically by let's say 10 to 15 variables, and out of that 10 to 15 variables, then we used to do manual. So manual approach, just like finding VF values, P values, and used to drop them, right? Now situation 2, just imagine situation 2. What is that? It's your data visualization. Data visualization. And what is that, guys? It's nothing but simple way, a lot of variables to visualize, right? My problem is I have, let's say, uh, first problem, a lot of variables to visualize, right? A lot of variable to visualize and explore. Second problem, I mean, solution to this is pairwise scatter plot or pair plot. Yes or no? What we used to do is we used to do the scatter plot or pairwise scatter plot or pair plot. Do you remember pair plot, everyone? Do you remember this pair plot? Right? So just imagine here, how many features do we have? One, two, three, four, five, six. So only six variables. I'm good to go with this pair plot. But just imagine you have 10, not 10, 100, 50, 50 variables or 20 variables. What will you do at that time? Right? This is good for me. Like solution is correct. But if we have 20, 100, 50 variables, is it correct way to go for this approach? Yeah, not certainly not, right? So for an example, let's say I want to visualize 100 variables. I have 100 columns in my data. In real case scenario, you guys also going to get 100 variables out of 100 variables basically, right? So so for 100 variables, you guys are going to have 100 C100 or whatever it might be, 100 C1 or something like that. So it is going to be 4950 uh, plots. You try to use this 100 variable combination, right? It is going to be 4950 plots. So it is practically not possible to visualize this 4950 plots, right? Manually, we cannot do. So the predictive model setup having a lot of correlated variables leads to multicollinearity problem, right? And iteratively removing features is time consuming and leads to some information loss for us. Data visualization, it is not possible to visualize more than two variables at the same time. More than two variables at the same time is not possible, right? Can we visualize more than two variables at the same time in 2D plot? Certainly not possible. Therefore, finding relationship uh, relationships the observations between the observations in a data set having several variables through visualization is quite difficult. Yes or no? It's quite difficult for us, right? Now, PCA helps in solving both the problems mentioned above, which you'll study shortly, right? So PCA will help you to solve both the problems. That's why I call it as we should call this as thalaiva for this problems, or we should call thalaiva, right? It's a thalaiva for us. It's a boss. So let's listen. Let's understand this following features to understand various applications of PCA. So applications of PCA, if you just write down, it will uh, it will understand, it will help you out to visualize every let's say 100 variables, 20 variables simultaneously. That is one case scenario, because you can see over here, right? We have how much variable? Multiple variables basically. So it creates multiple dimensions, dimensionality reduction. So first problem was related to higher number of variables, right? So it used to help us out in removing, reducing the dimensions, right? So what happens is, this is what we are going to learn, so don't worry about this. What happens is, I would say, let me explain this thing in very simple words, right? Applications of PCA. So first is dimensionality reduction. And what is that? What is that, guys? See, right? So we have M. So what's the dimension for this? M. Here it's N, right? What I'm trying to explain you is, this is M basically. This is N. This is M. So M cross N, right? So let me insert some shape if it is available. Let me insert some shapes. Drawing. Okay, we have this thing. Very good. Let me draw line like this, right? Save and close. We can take this. So my dimension, this is N, right? Suppose this is M, right? Now, dimensionality reduction technique meaning is reducing dimension from M cross N to let's say some smaller section. Let's say this one. Let's say only this one. Let's say 3 by 3, right? Just an ideal case scenario, like hypothetical, right? If you have 20 variables, 50 variables, you're just reducing that to 10 variables like that. So as this is M, as this is M, this is going to be M only. There's no changes in that. We are not reducing row, right? Rows are not interested. We are not interested to reduce that. We are interested to reduce columns because that is your variables. So that is your K. And what will be the criteria? N should be always greater than K. Then only your objective will be able to fulfill, right? For an example, N is 20 over here. K can be 10. K can be 5. K can be 15. So isn't it 20 is greater than 5, right? So that is your dimensionality reduction, right? So if K is less than N, or if N is greater than K, if K is less than N, it means we have achieved, we have achieved what? Dimensionality reduction. Simple. If K is less than N, it means we have achieved dimensionality reduction. Yes or no? Guys, are you guys with me till this point? Right? Then second application of PCA, that is data visualization. Data visualization. So let us put this as one. Let us color this as, let's say, this bold. My second is data visualization. Second is data visualization. Right? And what is that? It will help you out to visualize the data easily. Even though if you have multiple variables like 20 variables, 30 variables, if you just write down this on Google, PCA for price prediction or any data set, to be more precise, PCA for housing data set, let's say, right? And if you just go for images, can you see this? Can you see this? Uh, we are easily able to visualize the data, right? It is quite possible for us by using PCA. Simple. It's quite possible, right? I'll explain this thing, but at this point of time, just remember visualization is also possible, very easy. This is what we are going to learn in the other part of this session, right? So just I'm explaining this thing in very simple manner that visualization is possible. What about third part, EDA, exploratory data analysis? So if you just go with the MNIST, very famous data set, data visualization of MNIST data set, here how many columns do you have? Multiple columns. Um, I'll explain this dataset, basically what this dataset is all about. What do we have is we have handwritten images or handwritten numbers. So handwritten numbers dataset we have 1, 2, 3, 4, like that, 0 to 9, right? So it can be written in any. I mean, this is written by multiple people out there. So the way in which I write zero will be different. The way you write zero will be different. The way other third person will write zero will be different. Yes or no? Like that. Something like that, right? The way I write one will be, suppose, one like this. The way someone write one is this. The way other person, let's say Arvind or Arivali or Arun write one is again different. It's like this, suppose, right? So what we are doing is we are taking sample. Let's say this is a sample. So I think this is, if you just take size of this data, it will be MNIST data size. It will be 120 by 128 binary images. Or to be more precise, we convert this into pixels of 28 by 28. So every image is converted into 28 by 28 pixels, right? What is pixel? This is what we are going to learn in deep learning. But to give you guys an idea, pixel means every image consists of pixel. Yes or no? Everyone knows that, right? Suppose if I just capture one photo, right? If I just capture one photo, it has small particles or pixels like this. It consists of pixels, right? This, like this, right? This is one pixel, this is another. And the entire thing consists of an image. So at the back end, it will be pixels like this. So if you just take photo from a camera, let's say from iPhone, and if you just zoom it little bit, it will not stretch or it will not be blurred, right? But if you just take photo from any simple phone, let's say any um, what we can say budget phone, 10,000, 15,000 phone. So that photo will be if you zoom that little bit, it will be blurred, right? That will be blur. Why? The reason why it is not, I mean, it is blur for simple camera because of these pixels, right? So your iPhone camera or any good phone camera has uh, high level of pixels or something like that, and any bad camera will be having less pixels or less pixels you can consider. So immunized dataset also has 28 by 28. So what we are doing is we are converting our entire data into immunized entire data into single pixels like this. Like in one column, we have one pixel. One column, we have one pixels. Simple. So how we used to do that? By the way, what is this? What is this? Why we are getting? ठीक है, no problem. ठीक है. So what we are trying to do is, what we are trying to do is, we are trying to 28 by 28 pixels are there, right? Anyway, now you will not be able to understand it properly. Whenever we are going to see uh, computer vision or deep learning part, specifically image analysis part, at that time you guys are going to get this very clearly, right? So what I'm doing is I am converting each pixels at single column. So we have 28 by 28, right? And what is your size? 28 by 28. 28 by 28. It is 784. So I'm going to have 784 column. This is my pixel 1. This is going to my pixel 2. Like that, like that, like that, like that. Last column will be pixel 784. Yes or no? And another column will be digit. So this digit is 5, this is 4, this is 3, this is 2, like that. So I am going to have 784, 785 columns in my data. And in order to visualize that, it is quite difficult for me, right? So MNIST after PCA, visualization, if you see, it is going to be very helpful for you. Now it is going to be very helpful because it makes our task very simple to visualize data properly, right? Can you just imagine here we have 784 by 784 dimension. Just imagine. And it is making our task very easy. So can I say I can use this for my visualization purpose easily, right? Then fourth application is going to be your building predictive models. Building predictive models. So first is no multicollinearity. Second is faster models. Then third is okay, so we can have only 2 points. Okay, third. So we don't have multicollinearity, faster models because we are removing columns. So my computational time will be very less, right? In order to build predictive model with the 100 features, let's say time is 10 minutes. And if I just convert that into 10 features, 10 important feature, the time that I will require to fit this model is going to be 2 minutes, right? And this is just a last part, that is finding latent themes. And what is that? There is no any need for you. But if you still ask me what is latent themes, you can just have this figure. Image can help us out. Basically, figure tells 100 words, right? More than 100 words. I always believe this. Rather than just writing it down, we should write down it in uh, by using figure, right? So latent theme. Figure we want to see. I can give an example to this. Just give me a minute, right? Just a minute. For an example, if you have, uh, let's consider, let us consider you have movies dataset, right? What do you mean by latent? Finding latent theme is, suppose you have movies dataset, IMDb dataset, let's say, in which we have 20 lakhs of movie or 20,000 columns, right? And let's say 20 lakhs of movies you have, right? In order to understand this data set, it is very difficult for us, right? So what we do is we uh, convert our data to find hidden concepts in the data. Hidden concepts in the data means we categorize them into different features, like there will be action movies, there will be horror movies, right? There will be comedy movies. So genre wise, we are going to segregate the data out, and then we can build a recommender system, right? This is out of scope of your syllabus, but this is your entire crux of this part, right? And last but not the least is your scatter plot, is your noise reduction. And what is that? It's nothing but, it is nothing but data visualization of MNIST dataset, where we have 28 by 28 pixels. Noise will be very high, right? What do you mean by noise? Unnecessary data, unnecessary data. Noise reduction in PCA, right? Unnecessary data will be there. So you reduce your noise just like this. This is your example of noise reduction, right? We convert our data set, reduce our features for that particular data set, and unnecessary data will be removed. So a lot of noise will be there in the data. We are removing that. So this summarizes your entire applications of PCA, right? Even though last two part are little difficult for you or out of scope, but you should remember that, right? Now, uh, as we have discussed, latent theme, I would like to give you one more example. If you have a data set containing movies, different movies by Netflix users, right? So PCA would be able to find latent themes like genre and consequently the ratings that users give to a particular genre, right? Simple fact. Or genre or genre, I don't know what it exactly pronounced, right? Genre, I think it's genre. Yeah, genre. Yes. So that's what it is. This is your application part, application side of PCA, right? Now, let us go to what part of PCA, the what of PCA, the what of PCA. Let's go to that. What is that? What of PCA? So, what do you mean by dimensionality reduction, guys? A quick recap. What is dimensionality reduction, guys? It is a technique, helps in, it's an exercise of dropping unnecessary variables. Exercise of dropping unnecessary variables, right? So the following uh, session or following discussion will give you brief idea of what dimensionality reduction is and how PCA helps in achieving dimensionality reduction, right? So, uh, this is something which you already have done in EDA part, EDA of Google Play Store case study. Do you guys remember that? You have dropped the columns that had a lot of nulls or duplicate values, right? We have also in linear regression and in logistic regression, you dropped columns based on their p-values and VIF scores in the feature elimination step, right? Similarly, the what PCA does is that it converts data by creating new features from the old one, right? What it does is how PCA will help you out. What it does is it creates or converts the data by creating new features from old ones, where it becomes easier to decide which features to consider and which not to consider. Simple. Now that you have an idea about this, of basics of what PCA does is, let's understand the definition. So to give you guys an idea, comparison EDA, then we have linear or logistic regression, and then we have PCA. So how it will help? Let's create a table. What we used to do is we dropped null values or duplicate values. We dropped columns, p-values, and we have scope. And in PCA, what we have done is it converts data by creating new features from old ones. Simple, right? That's what the idea is over here. So the definition part now. So I'm going to give you a long definition. Anyway, you can get this in anywhere in on the web itself. Not necessarily you should remember that, but let's just write down that over here. So the definition side of PCA. It's a statistical procedure to convert observations of possibly correlated variables into new principal components such that this new principal components are new PCs are uncorrelated with each other. They're not correlated with each other. We are going to create new PCs. What is PCs? New columns, basically, right? PCs are nothing but new column. Just remember this thing at this point of time. PCs are nothing but new columns, new variables. So we are going to create new variables so that they are not uncorrelated, they are not related with each other. Linear combinations of what? Of the original values of the original values. So it's a statistical procedure to convert the observations of possibly correlated variables into new principal components such that this new principal components are linear combinations of original variables. Simple. And third is going to be capture maximum information such that new principal components are going to capture maximum informations of the data. Simple. So this is your entire definition side for PCA, right? So if somebody asks you, you should remember this. Anyway, it's not that difficult. You just need to have a good understanding. No need to mug this up, right? No need to uh, mug this up. So let's go to next. Now, the aforementioned definition introduces some new terms such as linear combination, right? Fancy words. Capturing maximum, capturing maximum information, for which you'll need some knowledge of linear algebra, right? You have to have understanding of some knowledge about the linear algebra, and as well as other building blocks of PCA as well as other building blocks of PCA. So in the next session, we'll start our journey in the same direction with the introduction of very basic idea of vectorial representation of the data. So these are the fancy words that we are going to understand. What will be the meaning of this particular words? Linear combination and capturing maximum information. So let us try to understand vectorial representation of the data, right? So let's go to math side of uh, this PCA, right? So this summarizes your one section where we are just try to understand the introduction of PCA part. Introduction of PCA part. This one, right? Fundamentals of PCA 1 and 2 is remaining that we are trying to understand that as of now, right? Chalo. Let us have Kahoot now. You guys will be having a quiz. So just give that quiz. Anyway, that quiz is something related to deep learning. Just use your, what we can say, guessing ability, right? Because we have not discussed that till now, right? So you guys are going to have a quiz now. Someone from GUI side will join, and there is a quiz part. There will be quiz on deep learning. So just guess. Don't worry about this. You just have to guess, right? Sure. If you have any questions till now, you can discuss. If you don't have any questions, I'll just write down the topic. Meanwhile, someone comes and start the uh, quiz part, right? Quiz part.
Um, Hi everyone. I will just take the count. So after that, you can continue with the session. Uh, Thank you, everyone. People, you can continue with the session.
All right, guys. So, what we'll do is now we'll try to understand fundamentals of PCA. That is first part, right? Let us see the mathematical part of this. So, even though it's boring, but you guys are going to get a lot of intuition about this, and nobody will help you out to understand PC in very simple manner, right? You can go to any article, any videos, any blogs, anything. You'll not be able to understand it in very simple manner, like we are trying to understand, right? As this is very complicated part, most of the people they feel it's not their cup of tea, or uh, the understanding side of this, that is which is we call it as notion, is little difficult to understand, right? But I'll try to make it very simple for you. At the end of this part, you'll try to understand. You'll understand it by yourself, right? Uh, Fundamentals of PCA. Understanding side of this notion is little difficult. So we learn about two most important building blocks of PCA. That is, first is basis. What do you mean by basis? Second is change of basis, right? But before, we'll go through a brief refresher of linear algebra concepts, right? We are going to understand this two part, because in this two part itself, everything is what we can say, everything is there inside in these two concepts, right? So the two part, the two side of this is basis and change of basis. But before that, let's try to understand vectors, matrices, and their inverse, basis vectors, change of basis, PCA, and change of basis, right? Let's try to understand that. So vector, what is vector, guys? What do you mean by vector? It's nothing but anything which requires direction as well as magnitude, right? So vector is nothing but this is your vector. Suppose A is your vector. Why this is there? It is known as direction. So it requires magnitude as well as direction, right? Let's not go into deep of this. Anyway, we have studied vector, right? In our school or in our higher school level. So what is vector? It's a term that refers to as quantities that cannot be expressed by a single number or the element, only single elements. You should have magnitude as well as direction, right? So I'll just copy this figure. Let me just take this out. Let me paste it over here. Sure. So what are their properties basically? What are the different properties that we have for vectors? Right? What are the different properties that we have for vectors? So addition of vector, how we can do addition of vector? Addition, then matrices you are going to see, and matrix uh, operations we are going to understand. That is matrix multiplication and matrix inverse, right? Matrix inverse. So vector, what is vector? So let's now suppose you have one data set. Let's say you have patient ID, height in centimeter, and weight in kg, right? So we have P1, patient 2, patient 3, patient 4, patient 5, and we have height in centimeter, that is 165, 155, 165, 160, and 160, right? We have weight in kg, that is 55, 71, 88, 105, and 94, 94, 105, right? These are the data. This is your data, which is with us, right? This is my data. So let's take this out, create data. Let's highlight this columns. These are the data for us. Now, I can represent this data like this. I'll just tell you how you can represent. You can represent your data like this: 165, 155, 165, 160, 1. Just a minute. Just Control X, Control V, and 160, right? And this is 55, this is 71, this is 88, this is 105, this is 94, right? right? Or you can write down like this, 165 comma 55, first line, 165 comma 55. Or you can write down like this, 165 55, right? The first row can be written like this or like this, right? First row can be written like this or like this. So basically, in order to understand the vector concept, let's take x-axis, we have height, and y-axis we have weight, right? So what is the first row? It's 165 as the height and 55 as the weight. So height, I'll just take 165. Let's say it is over here, 165, right? It is over here. And let's say 55, it is over here, right? So we'll write down this. This will be a point, and this will be a vector. This is going to be a vector. Yes or no? So likewise, you are going to have different vectors. 155, 75 will be somewhere over here. Sorry, 155 should be less, right? So somewhere over here, let's say here. Then 165, 88 will be somewhere over here. Then 160, 105 will be somewhere over here. 160, 94 will be somewhere here. So these are my vectors. Are you getting this? How to identify vectors or how to represent vector? This is my vector. So I can write down vector like this, or I can write down vertically like this. 165, 55. And 65, 55, right? We can write down like this. And as mentioned in the video, consider the following data set containing height and weight of 5 patients. These are the dataset height containing height and weight of 5 patients. The height and weight information can be represented in the form of matrix as follows, with each row representing a particular patient's data and each column representing original variable. Geogrammatically, these patients can be represented just like I've shown in the figure out there, right? Where was that? Suppose this is your figure, right? Let me take this. We can represent vector like this, right? This is my figure. The supposition, this is how we write down. So vector representation can be written like this. Vector representation can be written like this, 165, 55, or it can be written like this, right? And if we take transpose, what do you mean by transpose, guys? What is transpose? Rows become column, column become rows. So transpose simply means it is going to be represented as like this. So vertically we have represented, right? I want to convert that into horizontal. It will be 165, 55 transpose P. That is my transpose. So let us take this as well. Let us take this and let us paste it over here. Let us paste it over here. Right? Transpose is something you must have learned earlier in your school days or college days, right? And I can also represent vector as 165 I, small I, plus 55 J, right? I can also represent it like this. So where I and J are unit vectors along X and Y respectively. I is X directional unit vectors. So we can write down it as unit vectors. Unit vectors along x, and j is what? Unit vectors along y, right? These are known as basis vectors and used to represent all vectors in 2D space. Now, vector representation for n-dimensional data. So, for example, let us take three-dimensional law, right? Let us copy this, not Control X, Control C, and Control V. So, what if I have age column as well? Age in years. Just imagine 22, 24, 25, 27, 28, 29. What if I have this data with me, right? So each vector will contain values representing all the dimensions or variables in the data. For example, if there was an age variable also included in the above data set, the first patient had an age of 22 years, then vector representation for this is will be three-dimensional representation will be three-dimensional, right? That is 165, comma 55, comma 22. 165, comma 55, comma 22. Similarly, if the dataset had 10 variables, just imagine 10 variables, blah, blah, like this, right? We can have another different variables. So it will be 10 dimensions, yes or no? Vector representation will be 165, comma 55, comma 22, comma dash, comma dash, comma dash, comma dash, comma dash, like this 10 dimension. Yes or no, guys? So similarly, you can extend it for n dimensions or variables. Now, these vectors will have certain properties and operations associated with them. Let's go ahead and learn about this. All right, let's go ahead and learn about this. So I can represent any thing in uh, three ways. First way is comma. Any vector in three ways. First way is comma. Second is this. Second is, I think that image is not there. Second way is this, right? 165, comma 55. And third way is transpose. So there are three ways. Just remember this thing. There are three ways to represent a vector, right? There are three ways to represent a vector. Now let's go to operations in vector. So you can have addition operation of vector. How do you do addition? Simply suppose you have two vectors, let's say 165i plus 34j, and you have another vector like 155i plus 35j, right? How do you add this? This is A, this is B. How do you add this? Is addition will be 165 plus 155i, 155i plus 34 plus 35j. So it is going to be 165 plus 55, and it is going to be 34 plus 35. Sorry, 34 plus 35. B50y. Just a minute. 34 plus 35. Close this bracket. Right. 69. So it is going to be 2220i plus 69j. Right. Subtraction will be different. It is going to be 165 minus 55 plus 34 minus 35j. Right. So it will be 155. No, it will be 10i minus 1j or minus j. So how it is going to be, its direction will be negative. 10i x will be here. Suppose this is 10, but minus 1 will be here. Minus 1. So it will be here, and direction will be in this quadrant. That is your third quadrant. 320, is it? Okay, 320, no problem. 320 plus 69J, right? So the quadrant will be this, right? Last, not last, the third quadrant. This is your third quadrant, right? So vectors have a directions and magnitude. The magnitude of this two vectors is, let's say you have vector 2i plus 3j. How do you calculate magnitude? Is nothing but square root of square root of square root of 2 square plus 3 square. That is 4 plus 9. That is 15, na? 13. Square root of 13. So magnitude you calculate like this. Direction, you already know that. So this is going to be your magnitude of that particular vector. This is going to be magnitude of that particular vector. It's not allowing us to paste the image anyway. So magnitude is like that, right? Similarly, for 3 dimensions, let's say you have 2 minus 3, 4. It will be square root of 2 plus square root of 2 square plus minus 3 square plus minus 4 plus 4 square. So it is going to be, magnitude is going to be 2 square plus minus 3 square plus 4 square, right? Are you guys getting this now? Magnitude and direction. So addition, subtraction, we already have discussed. Multiplication is very easy. Now, let us try to understand matrices or matrix, because this is what we have it in your change of basis and basis of vectors. So what is matrix multiplication? How do you do that? So if you just take a figure of matrix multiplication, it is going to be like this. It is going to be like this. So let me take this out. Let me paste it over here. I don't know why image is not, I'm not able to paste it, or it's not visible in this. Insert image in a cell or over cell. Vector, not vector, matrix multiplication. This one, right? So this is a matrix multiplication. What is that? Suppose you have two matrix or matrices, 159 and this one. So how do you calculate multiplication? How it happens generally is it is going to be like this. See, this particular row, this particular row is multiplied with this particular column, or this particular row 159 is multiplied with this column 987. So it is going to be 1 into 5, sorry, 1 into 9, 5 into 8, 9 into 7, right? Then 1 into 6, 5 into 5, 9 into 4. Then 9 into 3, sorry, 1 into 3, 5 into 2, 9 into 1, right? Then 1 into 9, 5 into 8, 9 into 7. Similarly, you have 2 into 9, 6 into 8, 1 into 7, like that. So like that, the multiplication will happen, right? And the is rule for matrix multiplication is, you should also remember this. Rule for matrix multiplication is number of rows should be m cross n. Don't have this. It's very simple, right? I don't have an image for that. Yeah, let's take this. Let's take this. Suppose this is your matrix. Its shape is m cross m, means you have m rows, n columns. This is another matrix. Its shape is n cross p, means you have n rows, p columns. So the rule is this columns in your first matrix should be exactly equals to rows in second matrix. So this columns should be equals to rows in the second matrix. Then only you can multiply. That is your rule. Anyway, you guys must know this thing. This is nothing new rule for matrix multiplication or criteria, that it should be like that. Can you see this? Number of columns in the first matrix must equals to the number of rows in the second matrix. Is it clear for everyone? Yes, everyone. Is this thing clear? Can we move ahead? Right? As you saw in the video, as you saw in this, the process of matrix multiplication is quite simple, and there is some certain rule, right? Now let us try to understand the matrix multiplication, how we can do it in this Colab or in Python, right? Let's try to understand that. So I'm going to create two matrix and I'm going to multiply them. So let me add this as day 30 as PCA. Before that, let's add 18th Jan 2025 PCA, right? PCA Colab notebook, create and share. Uh, 18th Jan 2025 PCA, right? Let me put heading as matrix multiplication, right? So I'm gonna import numpy as np. I'm going to create two matrix np.array 1 comma 2 and 2 comma 3. Then np.array 4 comma 5, 6 comma 9, right? And then I have this a, which is this. Okay, what is happening over here is it should not be this, right? Again, this should not be the case. So these are my two matrices. A is this and B is this. You can visualize this, right? Now I want to multiply this. I want to do the multiplication. So matrix multiplication. How do you do that? You write down C is equals to A. You write an at the rate, right? This is another matrix multiplication at the rate. And if you just see, this is going to be this matrix multiplication. And if you write this one, A star B, it is going to be another matrix multiplication. So there are two matrix multiplications that we have. one is element wise. It just kind of this star, what it does is, guys, this star, what it does, it just do like this, element wise multiplication. 4, 5, 6, 9, right? 1 into 4, 2 into 5, 2 into 6, 3 into 9. 1 into 4 is 4, 2 into 5 is 10, so it is going to be 4, 10, 12, 27. Simple. 4, 10, 12, and 27, right? But this is another matrix multiplication. How it is doing, we already have discussed. So there are two matrix multiplications. One is element wise, another one is hmm, we have that row wise or element wise, something like that. Not necessary to know that, but there are two matrix multiplication. Let's go to next part. So that is what we have. That is how you do it in Python, right? Nothing difficult. Now you have another technique which is known as uh, another technique which is not technique, another thing which is known as identity matrix, inverse of matrix. Let's see that, right? So inverse of matrix, if you see, inverse of matrix. This is how we calculate inverse of matrix, right? So we have these two properties, like A into A inverse is always identity matrix. Everyone know this thing, not necessary to discuss this. So I should write down a heading, a quick heading as inverse of a matrix, right? Inverse of a matrix, right? To understand what inverse of a matrix is, we'll write down this, or we'll just see this. So how do you calculate inverse? We have seen this. So it's like this one, simple. We are not going to discuss these formulas. Or let's see this. Inverse of a matrix is this, right? This is how you calculate inverse of a matrix. And another property is identity matrix, means it's always diagonal elements are 1. So if it is 2 by 2, it will be 1 0 0 1. If it is 3 by 3, 1 1 1 0 0 0 0 0 0. Right? This is 3 by 3. Likewise, you can carry on, right? So the property is A into A inverse is always 1, identity matrix, right? It is going to be identity matrix. And then, yeah, that is your identity matrix. And in Python, how you can do the inverse is, let us see over here. How do you do inverse? Is my A is np.array 2 comma minus 1, 2 comma minus 1, comma 1 comma 1, right? And suppose this is my A. Suppose this is my A. I have another matrix that is B. Let me create another matrix that is B. B is np dot linear algebra dot inverse of A, and this is my B. This is my B. Then if I do again inverse, right? If I do again inverse, linear algebra dot inverse of B. Can anybody guess what will be the answer for this? What we are doing is what we are doing is this, we have this, right? We are finding inverse of this, that is A inverse. Again, inverse of this will be that matrix itself, right? Minus one, minus one. Inverse is that matrix itself. Yes or no? So if I just write down what is there in C, what is there in C, I'm going to get what I'm going to get. What am I going to get? I'm going to get the same inverse of matrix, that is C. This one, right? Is this thing clear to you, everyone? So that is how you calculate inverse in Python. That is how you calculate inverse in Python. Then next is basis now. So in order to understand basis, this was important. In order to understand basis, this is what was important over here, right? So basis basis simply means that I hope everything is clear till now. We are good to go with the basis now. It's a very simple concept, guys. Very simple. Let's say, for example, we describe weight of an object as in kilogram or in grams or in pounds, right? And so on. We describe length as centimeter, meter, and uh, kilometer, something like that, right? Then, for example, when you say object is of length 23 centimeter, what you are essentially saying is it is 23 into 1 centimeter, isn't it? So here, 1 centimeter is the unit in which you are expressing the length of the object. Yes or no? 1 centimeter is the unit in which you are expressing the length of the object. Similarly, vectors in any dimensional space, let it be any dimensional space, vectors in any dimensional space. Now you guys can connect the dots between the relation of basis and PCA, right? Now you guys get a more clarity about why we are learning basis. So vectors in any dimensional space or matrix can be represented as a linear combination of basis vectors. Yes or no? So let us discuss them in further detail in the following session. Let's unpack the ideas that you have learned. Suppose you have a vector as 1I. So suppose I plus j, right? So you can represent them in this way, right? A is equals to ax of I plus ay of j, or you can represent ax into 1 comma 0. I'll write down this. I'll just write down this. So I is what? 1I plus 1j, right? So ax into, this is 1, this will be 0, plus ay into, this is 0, this is 1, right? And this is going to be a, this is going to be equals to, right? So let me take this over here and let me just write down over here, right? This is what we have. right? Visually, it can be represented as, you already know. Visually, it can be represented as, this is 1. Let's say this is 1. So it should be like this. Oh, sorry. It should be here, no? So it should be like this. Simple. So this is how you can represent it visually, right? So, for example, vector 2 comma 3 can be written as 2 into 1 comma 0 plus 3 into 0 comma 1. Yes or no? Vector 2 comma 3. Can I write down like this? Yes or no, guys? Vector 2 comma 3, can I write down like this? 2i plus 3j. Can we write down like this? Right? So, for example, let's take that patient data set where we had this 165, comma 55 as the data set. Can I write down like this? 165, comma 55. Can I write down like this? 165 into 1 centimeter, 0 kg, plus 55 into 0 centimeter and 1 kg, right? I can write down like this. So I can just take this one, right? So I can do this. Simple. So therefore, now we can say that patient 1 is represented by 165. And similarly, we can express other patient information like this, right? Simple. So the basic definition of basis vector is that there are certain set of vectors whose linear combination is able to explain any vector in that space, right? So the definition side of basis is, what are they? They are certain set of vectors whose linear combination is able to explain any other vector in that space, right? So in a 2D space, the standard basis vectors are given by, in 2D space, standard basis vectors are given by 1 comma 0 and 0 comma 1. 1 comma 0 and 0 comma 1, right? In 3D space, we can give this as, in 3D space, we can give this as 3D space standard basis vectors are given by what? It would be 1 comma 0 comma 0, right? Then it will be 0 comma 1 comma 0, and it will be 0 comma 0 comma 1. So I'll write down this. Let's take this over here and let us paste it over here, right? So that is my 3-dimensional space. So as you can see, n-dimensional space or data set having n variables, you can represent it in this fashion. Yes or no? So there can be n dimensions and you can write down like this. So in next part, we'll learn how to use different bases to explain the same set of vectors. So ideally what we are doing is, we are doing change of basis only by using PCA. That's what the crux is. What we are doing is, we are changing the bases, and we are eliminating the dimensions. Very simple. So change of basis, let me have this introduction for you, and then we'll take a break. Right? So if you guys are, little, if you want break, just have a patience of 5 minutes, then we can have a break. So you understood the concept of basis vector now, how they are most fundamental units through which we can explain vector. Bases are nothing but most fundamental units through which you can explain the vectors. Right? Now let's go ahead and understand how you can use different bases of vector. How you can use different basis of vectors to explain the same set of vectors, right? Similarly, how you can use different units of to explain the same measure, right? For an example, to just understand this, let me just have conversion like this. We have 1 kg, that is exactly equals to 2.205 lbs pounds. We have 1 lbs, that is 0.45 kg, 454 kg, and we have 55 kg, 121.3 lbs, right? Now I can represent the same data set that I had earlier, this one. I can represent the same in the other units, right? My this data set can be written down in another basis, right? Change of basis. I can write down this. I can write down this in another basis, that is patient ID, height, and weight. Patient ID, height, and weight. So height this time I'm going to take in feet. Weight this time I'm going to take in lbs, right? So I'm going to have height as 5.4, weight as 121.3, and you can convert that to get this thing, that is 5.1 feet, 5.4. This is also somewhere around 5.2. This is 5.2, right? In lbs also, in pounds it is 207.2. This one will be 231.5. This one will be 194.0. This one will be 156.5. And this one will be 121.3. So aren't they both same, right? Are they different, guys? Are these two data sets different for me, right? Is it different or is it same? What's your thought on this? I just have converted it in another basis, yes or no? So are they different or are they same? Are these two different or are these two same? What do you think? It's same, no? So this is what the idea is behind PCA. We just change basis, that's all. We just change basis. So this is first for most fundamental element of PCA, that is basis, change of basis. Second is something which we are going to discuss in some other, you know, um, not other, after some time, right? So uh, in other basis, let's say I can write down this thing, that is 1 centimeter, 0 kg. I can write this down as 0 centimeter and 1 kg. Suppose this is my data. So I can write this down as like this. Uh, this one. 1 feet, 0 lbs, comma, 0 feet, 1 lbs. Right? The next is going to be 30.48 centimeter, 0 kg, comma, 0 centimeter, 0.453 kg. And this is what I'm going to get. So these are same. These three are same. Right? I can write down centimeter in feet, and I can write down 1 feet as 30.48 centimeter. Right? Same thing, no? Uh, Basically, not these two are same. Ideally, this is not the case. But what I'm trying to say is, what we are trying to understand is, I can write down 1 centimeter and 0 kgs in this unit, in this basis, right? Or I can write down in this basis. It can be changed multiple times, right? It can be changed multiple times. So feet conversion into centimeter, lbs conversion into what we can say kgs. That is something which we are going to do. So let's move to next part. Or before that, I think you guys should have a break because we have discussed theoretical part. So let's have a break before actually moving to the next part, right? So like I'll just write down one thing, that is we have, or you have, the flexibility of choosing a different set of basis vectors apart from the standard basis vectors that are provided you that are provided to you to represent your information, right? And the information won't change, right? Just the numbers representing the information would change. That's all. Just the number representing information would change. Yes or no, guys? Is it clear? Is this thing clear? Now, having said this is fine, but I want to do this in Python, right? So let's try to do it in Python. But before that, let's have break till 11, 13 or 15 a.m., right? So let's have something. Just go and have your coffee or anything. Just uh, freshen up little bit, and then we'll see some. Again, we have some calculations, mathematical side, before actually moving towards PCA in Python, right? So let's have a break. All right, guys. So the next thing is change of basis calculations, right? So for an example, what we can do is, yeah, suppose if I have data in feet and weight in kg or weight in lbs, I can convert this like this, right? We can use this thing, or we can convert this from this to this, right? Now, uh, let us start from the basic, very basic. Let's say change of basis calculations. In the previous segment, you saw a demonstration of how to change, how the change of basis led to dimensionality reduction. How change of basis led to dimensionality reduction. Yes or no? So let's go ahead and understand the elegant way of doing the same calculation, right? My new basis representation, that is in centimeter, is equals to m times old basis representation, that is feet, right? Centimeter I can represent m into old basis representation, yes or no? So that is going to be m over here is going to be 30.48, because centimeter to feet, if you do centimeter to feet, so 30 centimeter is equals to 1 feet, right? 30 centimeter is equals to somewhere around 1 feet, 30.48 to be most precise. 30.48, right? So my m over here will be 30.4. I'm going to the other side, going the other way around, is my new basis representation, that is feet, is m inverse type times old basis representation. Yes or no? That is centimeter, right? And my m inverse is going to be 1 upon 30.48, 1 divided by 30.48, which is going to be 0.038, right? This is going to be my inverse, my m inverse. That is this one, right? Is it clear now, everyone? Is this thing clear? So that is how the change of basis in one dimension follows. This is change of basis in one dimension, guys, right? Change of basis in 1D, because this is one dimension only. We are considering only one dimension. My that is my height into, I mean, centimeter into feet, right? Now next part is basis is 1 feet 1 centimeter. This is again 1 feet 30.48 centimeter. This is going to be 5.4 feet. How many centimeters? How many centimeters? You can calculate that, 5.4 feet in centimeters. So that is how the one dimension change of basis is, right? So what is m over here and what is m minus over here? So my m is representation of old basis, that is feet, in new basis. And what is my m inverse over here? It's a representation of new basis, that is centimeter, in old basis, that is feet, right? That is feet. Simple. So M inverse is representation of new basis. Just a minute, guys. Representation of feet. Let me just highlight this to, let's say, red color, and centimeter also to, let's say, red, right? This also. This is my centimeter, to highlight this to red color, and feet to red color. Red. Simple, right? So what if you want to go other way around? Other way around is, let's say, surely you cannot go ahead and simply take reciprocal, right? This is where the concept of metric inverse comes into the picture that we have discussed. Other way around should be, let's say, uh, let us take this diagram. Let us take this diagram, this two, and let me take it over here. Let's say here, right? First way we have already discussed, right? What is that? 30.48, 0.45, and uh, into, it just kind of 30.48. This is my centimeter. Weight to lbs, what is that? Weight to lbs. Weight to lbs, it is kg to lbs, basically, not pound. Kg to lbs. 1 kg is 2.2, right? 2.204 pound. So other way around will be 1 pound will be 0.453592. So here my centimeter to feet is 30.48, and my feet to, sorry, kg to lbs is 0.45. Simple, right? So I have to multiply this. This is going to be my m. In other case, how can this be 30.48, 0, 0, 0.45? If you just multiply this first row with this, you're going to get what? 5.4 and 121.3. This one, right? Let us try this out, right? Let us try this out. So I want to do matrix multiplication where my A is going to be this 165 and 55. So A is equals to np dot array 165, 55, right? Then B is equals to, uh, not B, B is 30.48 and 0, 0 and 0.45. 30.48, 0, 0, and 4. It would be like this. Let's say B is this. So I'll just copy this. I'm going to paste it over here. This will be 30.48. This side it will be 0. This is again 0, and this is 0.45, right? Now if I just multiply with A1 and this is B1, if I just multiply, um, what is this? Okay, comma should not be there. Is it? Only one bracket should be there, or two brackets. 165, comma, yeah, comma. Yeah. Then if I just write down C1 is equals to A1 at the rate B1. And if you just print C1, as I have done this twice, so I'll not get the answer. Let's restart and run all this. So what I'm doing is I'm demonstrating if I multiply 165 comma 55 to this, I'm going to get 5.4 and 121.3. So this is just Python representation of this. Can you see this? Okay, isn't it the way in which we want? This is fine. So isn't it too? Oh, we have to represent this in 2 dimension, right? This one should be 165 comma 0, right? And again you should have comma, and again you should have 0 comma 55. Then that will be the correct one. What has happened? Yeah, this should be the case. So here we have another bracket, right? And if I just print A1 B1, this is perfect, and this will be my answer. So I should restart and run all this. Anyway, so I'll represent. Let's see this in Python some after some time. But that's it. That is what we have, right? In other case, other way around, if I have to do from height in feet and lbs to centimeter and kg, from height in lbs to centimeter, height feet to centimeter, lbs to kg, what we should do is we should use which one? That is m inverse, and that is going to be my 0.0328, 0.0, 0.0, 2.22, this one, right? That is my m inverse. That is going to be my m inverse. So if I just multiply 5.4 into this, I'm going to get 165 comma this. So other way around, right? Other way around. You just try this multiplication, you're going to get the answer. Now, that is what we have. So in the next segment, we'll go ahead and generalize the idea of change of basis using some more solved examples, right? So what do we have is, let's say I have this one, right? 1001. Another example to understand this. Example number 2. I have this 1001. I'm multiplying this with 5.4, 121.3. And what I'm going to get is I'm going to get 0.028, 0.028. Or in other way around, let me just simplify this for you. Suppose I have 5.4 feet and I have 121.3 lbs. Let's take this one. Let us take first. I have this, right? That is nothing but 165 centimeter, 165 centimeter, 55 kg, right? In other words, we can write this question as 5.4 into 1 comma 0 plus 121.3 into 0 and 1 is equals to 165 into 1 0 plus 55 into 0 comma 1. What is this? This is nothing but this one only, right? Plus this is equals to this plus this, right? Just a minute. So this is going to be this plus this is equals to this plus this, right? This is my feet and this is my lbs. This is my centimeter and this is going to be my kg. right? So let's take this equation and let us calculate or write down some formula. So what we are going to do is, what we are going to do is, we can write down this in other way, like this. I have this matrix, which is 1 fit, 0, 0, and 1 LBS, right? I'm multiplying that with 5.4 and 121.3. This is nothing but same as 1 centimeter, 0, 0, 1 kg. And this is nothing but 165, 55. Simple, right? So keeping everything in the same coordinate system, I'm just keeping everything in the same coordinate system. So I'll just take a screenshot of this first of all. I'll remove this. I'm going to add it over here. I'm going to add it over here. Now, I'm going to keeping everything in the same coordinate system, which is 1 feet, 0, 0, and 1 LBS, right? And 5.4 and 121.3, right? Is equals to 0.038, 0 feet. This is 0.02, sorry, 2.2. This is 2.205. I know this is a little bit boring, but let us see this thing. Then we'll start some practical part, right? This is 165 and this is 55, right? Keeping everything in the same coordinate system. So let me just put it over here, keeping everything in the same coordinate system, right? Let's do that. So can I say like this? If this is my B1, this is my V1, this is my B2, this is my V2. So can I write down B1 into V1 is equals to B2 into V2? I can write down this, right? This is my equation. B1 into V1, this is B1, this is V1 is equals to B2 into V2 is equals to B2 into V2, right? Now, here again we are going to deal with this equation. What is my B1? It is one set of basis vector. B1 is point representation in B1. B2 is different set of basis vectors, and V2 is same points representation in V2, right? Using this equation, we'll derive the value of M. Using this equation, we will derive the value of M. What is that? What is that? It's nothing but Remember, we already earlier have said that new basis of representation is equals to m times. Do you remember this? M times old basis of representation, right? This was my equation. So let us take this. That is new basis of representation. That is B2 is m times what? B1, right? So comparing these two equations, comparing these two equations, where I can say V2 is m times of that is V1, m times of V1. For an example, what is V2? V2 is in feet. What is m? So the conversion, basically conversion. And what is V1? It is in centimeter. So feet to centimeter. How do you convert that? Let's say 1 feet. M. What is that? Feet to centimeter conversion. 30.48. So my M is 30.48 over here. And V2 is 1 centimeter. Yes or no? So I can write down this, right? Now what I'm going to do is V2 ka value, this V2 value is going to be, we'll just put it over here. This value. Or we will just multiply B2 inverse by both side. B2 inverse by both side. So this is going to be B2 inverse into B1. This is going to be 1. This is going to be B2. And my another equation is going to be V2 is equals to V2 is equals to B2 inverse B2 inverse into B1. So let me take this out. Just a minute. Just 5 minutes, guys. We are going to do this 5 minutes for 5 minutes and then we'll see practical part. Right? So just, I mean, I understand this is a little, what you can say, boring, but let's discuss this for 5 minutes, just 5 minutes. What I'm going to do is I'm going to multiplying this with B2 inverse. I'm going to multiply this with B2 inverse, right? This is going to be B2 inverse into B1 into B1. This is going to be B2 into B2 minus B2 inverse. This is going to be 1. And this is only right hand side. It is going to be V2. Yes or no? So I can write down V2 is equals to V2 is equals to B2 inverse into B1 into V1, right? V2 is equals to B2 inverse into B1 into V1. Let's consider this as equation number 2 and let us consider this as equation number 1. Equation number 1, right? So I have equation 1, I have equation 2. Let me just, highlight this with little different colors. Let's 15. This is my equation 1. This is my equation 2. This is my equation 2, right? Equation 2. Now, on comparing this, both the equation, that is equation 1 and equation 2, just compare this to what you are getting. V2 is equals to M into V1 and V2 is equals to B2 inverse into B1 into V1. Yes or no? Yes or no, guys? So can I say, uh, this one, that is M into V1, M into V1 is equals to B2 inverse into B1 into V1. Yes or no? And V1 can get cancel each other. This side V1, this side V1 can get cancelled. And what is left with us is new M value. What is that? B2 inverse into B1. Simple, right? B2 inverse into B1. This is what the idea is. This is why we were doing this thing, right? So this is my formula, right? Now Uh, so mainly we are just moving between multiple basis vector. It is important to know that the point's position in space does not change, right? For an example, this is suppose, let's for this point 165 centimeter, 55 kg. Suppose it lies over here, right? Same I can represent it in feet and centimeter. So 105 centimeter is how much feet? 3.44, right? Or 105 is okay, 3.44 feet, and 55 kg into lbs is nothing but 55 kg is 121.254, right? So in other, so this is what? This is centimeter, this is kg. In other plot, even though you are changing basis, guys, this is very important. Even though you are changing basis of vector, but but your position will not change. Position of this point will not change. It will be like this only. So a little bit different up and down, but position will not change. What I'm trying to say is my position will not going to be change. Position of point. So if I just draw it in the same dimension over here, if I just draw it in the same dimension over here, my position will be here only. Let it be any basis. Let it be any basis. This is my feet. This is my pounds, lbs. Is this thing clear now, everyone? Is it clear for you? Do you have any questions in this, guys? Anybody has any questions? Chalo, if you don't have any questions, let us go to the practical implementation of change of basis. So, as I told, this is really, really difficult concept, but I'm trying to explain this in very simple fashion. You try and go to anywhere. Let's say I'll share some videos. You go over there, PCA stats quest, and you watch any video out there, guys.
The
Right?
line.
You try to watch any video. It will be very difficult for you to just have an idea about this. What is this change of basis and this, right? Now let us quickly do this change of basis in Python, right? So what I'm going to do is I'm going to write down change of basis, that is solved example. Same example we'll take to understand this. So first of all, import. Already we have imported, but let's import again numpy as np, right? A few conventions before we proceed is by default we'll assume original basis as b1, new basis as b2. By default, we will assume original basis as b1 and new basis as b2. Then original vector representation is denoted as b1 and the new vector representation as b2, right? Then matrix M to be multiplied with v1 to obtain v2, right? So case 1 now, my case 1. What is that? I'm moving from the standard basis to a non-standard basis, right? In this scenario, in this scenario, you are given points. In this scenario, you are given a points representation in the standard basis. Your task is to identify the same points representation in a new set of basis vectors. So my question is, let's say you are given a point P, which is represented as V1 in the standard basis B1 as shown below. This is your question, right? So V1 is represented as 4, 9 in B1 is equals to 1, 0, 0, 1. So how to write this now? Just a minute. B1 is 1001, guys. B1 is 1001. So 10 and 01, like this, right? Now you need to find the same points representation in a different basis B2, which is denoted as follows. Let me take, I already have created this. Just give me 1 minute. I'll just take everything what I'm writing down over here so that you can get an idea about that. Very simple. Very, very simple. Just give me a 1 minute. Just a minute. What I'll do is I'll just download that. Yeah, just a minute. PCA is here. And change of basis that we have seen It is here, right? Here. This is my zip file. Yeah, I'm just going to upload this on your drive. So what I want is I want this entire, right? Yeah, this is what. Yes, yes, perfect. So I'll just take this one, Control C, Control V, and let us upload it on your drive here in PCA. Folder upload. This one, 3 files. Right, it's already done. So the notebook, this is your notebook. This is what I'm talking about. See, now, yeah. So by default, we'll assume the original basis as B1, new basis as B2. Original vector is denoted as V1, right? And new vector representation as V2. Matrix aims to be multiplied with V1 to obtain V2. Moving from the standard basis to a non-standard basis. In this scenario, you are given a points representation in the standard basis. Your task is to identify same points representation in a new set of basis vector. Let's say you have given this point P, which is represented as V1 as vector in the standard basis of this 1001, right? And you need to find the same points representation in the different basis B2, which is denoted as this. So B2 representation is this 1, 2, 2, 3. And point B2 is in B2 is 3, 1, like this. So let us do that. Let us do that. Step number 1 is denoting the new basis vector as numpy arrays. B2 we have given, that is 1, 2, 2, 3. We'll create that. This is my B2. Then I'll write down np.array. In that arguments I'm going to write down. So this is what we have created, right? Now step number 2 is create the transformation matrix M. And what is that? M is equals to B2 inverse minus into B1. M is equals to B2 inverse into B1, right? So we'll create that. Basically, since B1 is a standard basis vector, which is also an identity matrix, can you see this? Our B1 in our case is identity matrix. So anything multiplied with this, suppose I multiplied with this, like this. Anything multiplied with 1 is only that same thing, right? So if I do B2 inverse into B1, which is my 1001, what will be the multiplication? So it's kind of B2 inverse into 1. My B1 is 1, no? So B2 inverse into 1 will be B2. B2 itself. This is my B2. That is B2 inverse. So my M is B2 inverse. So I'll write down M is equals to NP dot line linear algebra inverse of dot inverse of B2, which I have created over here. Then my M is this. I'm doing matrix multiplication M into B2, because if I just simply take it over here, this M is equals to B2 inverse, right? So M, if I take it over here, it will become M into B2, right? It just kind of like this, M is equals to 1 divided by B2, right? M is equals to 1 divided by B2. It will come over here. M into B2 is equals to 1, right? Isn't it 1 now? It's 1. Now step number 3, perform the change of basis. We know that in order to get V2, we have the equation as V2 is equals to M into V1. V2 is equals to B2 into B1, B2 inverse into B1 into V1. That is M is equals to, sorry, V2 is equals to M into V1, right? V2 is equals to M into V1. V2 is equals to M into V1, right? So let us do that. We have V1, which is 4, 9. You have some work, Gopi. Yes, yes, you can leave. No problem. So V2 is 3, 1. Sorry, V2 is V1 is 4, 9. So we'll define that 4, 9. And we'll do V2 is equals to M into V1. V2 is equals to M into V1. So we have M. This is my M. And we have V1. This is my V1. So I'll do matrix multiplication. I'm going to get V2. So it just kind of 4, 9 can be represented in other basis of vector as 3, 1. So it's just like, just imagine this is kg, this is feet, sorry, centimeter, and this is lbs, and this is feet. So it just change of basis we have done over here, right? Just kind of change of basis. Is this thing clear now, guys? Do you have any questions in this? Yes. Anybody have any questions in this? Yes. What about other guys? Abdul, Arvind, Chandramohan, Darshini, Ishwarya, Kannan, Madhu, Maulya, Prasita, Sai Darshan, Sharmila, Varun, Karthik. What about you guys? Do you have any sort of questions till now? Any questions till now? Okay, fine. So that is what we have seen. Now, so just imagine this is just like just I'll just put one question over here. What is that question? What is that question? Is nothing but uh, just imagine you went to different planet, right? For exploratory exploration purpose, right? To find intelligent life there, right? You met an alien and you started showing it where you came from and location of Earth from that planet, right? And you realize that the basis used by the alien is not the same as yours. Is not same as yours, right? You use the basis as B1 as 1 and 0 and 0 and 1 like this, 0 and 1, right? While alien uses B2 as 1 and minus 2, 1 and 1, right? And now you have to answer this question. So this is going to be your homework. So it's not, you can do it by the same thing which I have provided. This is going to be your homework. Your question one is, you have question one is, you want to tell the new alien friend about the beautiful Saturn. You want to tell the new alien friend, FRIEND, about the beautiful Saturn, right? And the location of Saturn in your basis is 25, 28, right? And what is the representation of the same alien's basis? Location of Saturn in your basis is 25, 28. And what is the representation of the, excuse me, same in aliens basis? What will be that? This is your first question. Now, question number two is alien also tells you the location of the planet that also has intelligent life. So, alien told you the planet has, the planet, let's say Kappa, has intelligent life, right? The position of that planet, Kappa, in aliens basis is -3 and 12, right? Now, to make this information useful to Earth people, to make this information useful to Earth people, you have to convert the position to Earth basis B1, right? And the representation of kappas in aliens basis is -3 comma 12. So your question is, what is the representation in your basis? In your basis. Simple. Are you guys clear till this point? Can you solve these two questions as part of your homework? Yes, guys. What about other guys? Now here comes the idea of PCA and change of basis, like how or why we were focusing and scratching our head for this point from past 2 hours, right? Why we are trying to learn change of basis. The idea is this, right? So let me just continue this session till 12:30, guys. Let's continue till 12:30. Let us finish this, right? Let us finish this. So please be with me till 12:30. Anyway, this is very interesting and very important for you. So you should devote this time, right? So in the previous segment, you learned the concept of basis and change of basis, but you might wonder what is the role does, like what role does it have to play in in PCA, right? What will be the role? Let's understand how the change of basis plays an important role in the case of dimensionality reduction. So what it does, PCA, what it will do is it will find the new basis of vector for us, first point, and this new basis vectors are also known as principal components, and we represent the data using this new principal component by performing the change of basis calculations, right? And after doing this, after doing the change of basis, we can perform dimensionality reduction. In fact, PCA finds new basis vectors in such a way that it becomes easier for us to discard a few of the few of the features. It becomes easier for us to discard few of the features. Like PCA finds a new basis of vector, PCA find new basis of vector, and new basis itself. Suppose in original dataset you have 100 features, right? In new dataset or in or your original dataset, you have 100 features or 100 columns. After doing PCA, after finding new basis, it becomes easier for us to discard few features. Like it will be 20 features or it will be 30 features directly, like that, right? So I have added two figures in your um, drive over here. So if you just check this thing, now this is very important point, guys. Now we have come. Uh, we are discussing the conclusion part of PCA. Whatever we have discussed from 9 a.m. onwards, we are discussing the conclusion side of that. So PCA does this thing. Theoretically, we have discussed that. Everyone is good with this, right? Theoretically, will be getting this thing. Sorry. Uh, Theoretically, you guys will be getting this, right? But practically, what happens is, let's take an example. Like you have point, you have x coordinate, and you have y coordinate of that. The point is P1, P2, P3, P4, P5, and P6. X and y coordinates are 2, 3, 4, 6, 7, 8. Y coordinates are 1, 1.5, 2, 3, 3.5, and 4. Right? So this is my table. This is my table. Simple. This is going to be my table, right? Now, what I'm going to do is I'm going to draw this thing on x and y axis, right? So what we'll do is we'll just take this and we'll kind of insert a graph, a scatter plot, which follows this, right? So y versus x, right? This is your y versus x, right? Now, next thing is, suppose your new basis of vector from PCA are, suppose you have of new basis vectors from PCA. In this case, we have this thing, right? 0.8944, 0.4472, and minus 0.4472, and 0.894. So these are my new basis of vectors, right? So, so my new x is going to be, if I just do this calculation, everything, if I just do like this entire thing, right? This entire thing. So what happens is, what happens is I get this point, this x coordinate, x new, and y new. This time it will be new. Point is same, P1. So I can copy this, Control C, Control V. X new will be changed 2.24, 3.35. You do the calculation, you will get the same thing, 6.71, 7.83, 8.94, right? And my new y new will be 0, all 0. That's why I am doing this thing, right? The entire purpose of doing this is I want to reduce my dimension from 2 dimension to 1 dimension by using this change of basis vector, right? My whole idea is to convert 2 dimensional data, higher dimension into lower dimension, right? That's why we are doing this. Now, if you just plot this, if you just plot this thing, insert, chart, scatter plot, it will be this, like this. Are you guys getting this? So what we are trying to achieve is, what we are trying to achieve is over here is nothing but it will be the y coordinate side will be this. So ideally what happens is this will be y coordinate only, but and this will be x new coordinate. Sorry, this will be y. Okay, this will be x new and this will be y new. All are 0. But what happens is, this is what has happened. We have tilted this like this, right? This is my y new and this is my x new. Are you getting this? So that's why it has become like this. Are you getting this point now, everyone? So what does change of basis has achieved for us? Are you getting this, everyone? So by using change of basis, we just kind of tilted our axis from this to this like that. Originally it was like this. Originally it was like this. We have tilted through this thing. And we are able to reduce our dimension, one dimension, right? So my y new is not new, what is not necessary for me now, right? I can only have x new because all it is 0. Are you guys getting this fact easy? So this is your summary, right? This is going to be your summary. That's what we have seen. Is it clear now, everyone? Anybody has any doubt? Anybody have any questions in this? Where was that merge? I did merge, but I even forgot where. Format में ही था ना, I think. Alignment. No. Just a minute. Let me just merge this thing. Data. Not in data. Format. Merge cells. Yeah. Merge all and center. Perfect. So this is going to be a summary. This is going to be a summary. Simple. So can you see this? 2 dimension we have converted into 1 dimension. This is not required for us. So basically I can write down a 2D data set has been simplified to a 1D data set. 2D data set has been simplified to a one-dimensional data set. Yes or no? So that's how you do. This is your summary of this entire. So again, I'm going to give you guys two questions based on change of basis. And then we can stop here for the day. So you are given vector number 1. You are given vector number 1, that is 3, 2. And you need to find its representation on a new basis. That is 3, -3, 4, and -5, right? So what will be the change of basis? That is M you have to find in this scenario. This is your first question. And second question is going to be, now that you have calculated change of basis, that is you have M with you. Now compute vector, which vector? This 3, 2 vector in the new basis, in your new basis. Do this thing. So basically in new basis, you have to calculate the vector. That's your two part, right? Now let us summarize what we have discussed till now, and then we'll stop here for the day. So the summary part is that was the end of a quite hectic session. Here's the summary of what you have learned so far. First, you came to know about PCA. About PCA and how it is essentially a dimensionality reduction technique. You saw the necessity of doing PCA in a couple of situations, like uh, necessity of PCA in a predictive model, right? Where there are a lot of features to eliminate. Then a data set where you needed to perform EDA and data visualization, right? You understood how PCA not only helps in resolving about this two issues, but also you have seen application side, applications of PCA, right? And uh, in several areas like noise reduction, finding latent themes, right? And so on. Then you got a brief understanding of PCA, that is, it is a statistical procedure to find principal component of directions that are these are the applications that we have discussed. Then we have seen PCA is a statistical procedure to convert observations of possibly correlated variables into new principal components, such that these new principal components are new pieces are uncorrelated with each other. There are linear combinations of the original vector and capture maximum the dataset. So we have seen this definition. That was the next part, right? So it was here, right? This is your part. Now, after that, you went ahead and learned about some essential linear algebra concepts like vectors, their properties, right? Properties. Then, uh, then we have seen uh, matrix multiplication, right? And matrix inverse, right? And both of which proved invaluable understanding of the first fundamental building block. What is that? Of PCA is basis, right? As I told, this is first fundamental building block. Second is second is variance, which is not discussed yet. We have not discussed this. And basis is essentially fundamental units in which you express your data. After you saw how physical quantities like height and weight can be uh, represented in feet and centimeter, like that, right? Change of basis we have discussed, right? Then you learn one of the key ideas that help you to connect basis vector, that is idea of dimensionality reduction. You have to using different basis vectors different basis vector to represent the same point, right? And if you are moving from basis space B to B1, so we have seen this calculation, right? We have seen this calculation. And what is that conclusion? That is V2 is equals to M times V1. This is your conclusion from this output. Simple, right? So that was your entire summary. I have summarized this thing. If you have any sort of questions in this, you can ask. Otherwise, we'll just stop here for the day. I'll write down 19th Jan 2025, which is nothing but in that we are going to understand the second fundamental building blocks of PCA, that is variance. And it's very simple now, not that difficult. Second fundamental building block of our saliva of PCA is variance. Is it clear? Do you guys have any question? Do you guys have any doubt in this? Anyone? Anyone wants to discuss anything? Yes, guys. I'll I'll give you 4 minutes. If you still have 4 minutes to ask questions, if you have any. Why you guys are not responding? Is it clear or is it was bouncer for you guys? Yes. Yes, everyone. But I need to rewatch this session to understand clearly. See, that's what I told, right, guys? See, this is very, very important. I'll give you one challenge. You can, try to learn PCA by yourself, and you'll not be able to get this, right? You go anywhere. Even I was struggling when I was trying to study it in the first time itself. You understand the essence, that's fine, but you don't understand the mathematical part of that, right? You will not understand mathematical. You just try to,
maximizes the sum.
watch n number of videos in Hindi, in English, or in any language. You'll not be able to understand or get the mathematical part in the first go itself, right? Even I spent a lot of time on this, one iteration, second, third, fourth, fifth, sixth. Then I got the entire notion of this. Now, I mean, before trying to, explain to you guys, right? So I did a lot of efforts. I spent a lot of time to understand this, and then try to summarize this in very simple fashion so that I can teach it in, let's say, 2 to 3 hours. But still, it's not sufficient for us, right? So idea here is to just give you guys everything, mathematical side, intuition side, its advantage side in very simple words, right? That's why we have studied this, and that's why we have had extra class today, right? So all right, then still have if you still have any questions, you can ask. Yes, Murli, yes, you should watch it again and again and again. Yes, Varun, just try to spend a lot of time for this concept, because this is what is very important for us, right? This is what will separate you from other candidates in terms of interviews, in terms of anything. Like if you just explain this particular part to the interviewer, you will see that uh, like it will be another sort of impression, right? You will find that um, like even they are not expecting from a fresher candidate or any sort of candidate that he is explaining like this, right? So it will be a wow factor for everyone. It is going to be definitely a wow factor for everyone, right? So that's what we have. We'll stop here for the day. Thank you, guys. Happy learning. And just revise this. So that's what we have. Thanks. Thanks, everyone. Bye.